Unit 3 is definition of derivatives and tangent lines. Lesson 3.1 is finding an average rate of change from a graph and slope of secant line. So we've got some kind of vocab that we're learning here. We've got a function below, y equals f of x. Plot a line segment connecting the points on f where x equals -2 and x equals 3. So all you're doing is finding where x is -2, which happens to be right here at -2, 0. And then where x equals 3, you'd find x is 3 and then find the point that's on the line. So that is between -8 and -12. This must be -10. So this point would be 3, comma, -10. We're going to then make that a line segment. So on Delta Math, it'll just connect it for you. But I'm going to get a ruler and make a line real quick. Something like that. It says use the line segment to determine the average rate of change of the function from -2 to 3. Average rate of change is really just slope. But it's like an average slope because you can see our function from -2 to 3 is curved. We have not yet learned how to find the slope of curves yet. But from algebra, we know how to find the slope of something that's linear or straight line. That's just the slope formula, m equals y2 minus y1 over x2 minus x1. Other thing you could write it as is this triangle that's called delta y. That means change in. So when you see a little triangle in math, that means change in y over change in x. Rise over run, if you will. So all you're doing in this problem is finding the change in y. So you could literally just think from here to here, from 0 to -10 is going down 10, and then going right from -2 to 3 means you're going to go 2 plus 3 more, you're going right 5. So going down 10, right 5 would get you actually a slope of -2. Now, if you don't want to look at it, just do slope formula. If your points are this, -2, 0, and 3, -10, just do y2 minus y1, so that'd be -10 minus nothing, over 3 minus -2, which would be 3 plus 2. And you'll get -2 as well. That's all you're doing. So average rate of change, this is actually called a secant line, which we'll see here in just a second. It touches the line in 2 spots. It's not a perfect slope, but it's a good average or estimate of it. So a secant line is a line that goes through a function at 2 distinct x values. Slope here, m, the slope of a secant line, is f of x2 minus f of x1. This is like y2 minus y1, but it's f of x's, which is y. Fancy way for writing y. So slope's the same thing, but now let's try to do it without a graph. So we've got -2x squared minus 5x minus 9 is our function. Find the slope of the secant line between x is -3 and x is -1. So the easiest thing for me to do is to go ahead and make ordered pairs saying, okay, when x is -3, what is our y value? When x is -1, what is our y value? You've got 2 different ways you could do that. I could put the function in, my y equals, and graph it. I don't like the window. If your window's messed up, go window. Oh, go window. Make it go -10 for your minimum of your x to 10, count by 1. -10, 10, count by 1. Let's try that. Ooh, that didn't look very good. Okay, so it's a quadratic and it's negative, so it's flipped upside down. So I can't see it all. But then I could go secant calc value, so secant trace value, and when x is -3 is what I type in, hit enter, and it'll tell me y is -12. So it actually tells me the y value when x is -3. I could do it again. I think I can even just type in, yeah, I can just hit -1 and that says x equals -1. It tells me the y value with that is -6. So that's one thing. You could put it on your graph. You could do this on Delta, or not Delta Math, the Desmos as well. Or you could simply plug it in. Say -2 times -3 squared minus 5 times -3 minus 9. Got me -12. And then you could come up here and steal this, and then you could actually then change it to -1 instead and get you -6. But either way, you're doing those points. So now I'm just finding the slope of the secant line, which is literally just finding a slope of this straight line by doing y2 minus y1 over x2 minus x1. So it would be -6 minus -12 turns into positive over -1 plus 3. That would be 6 over 2, which is 3. But again, this is going to be important moving forward. So you would think f of my x2 would be f of -1 minus f of -3 divided by -1 minus -3. Because f of -1 says when x is -1, what is y was -6. And f of -3 meant what was y when x was -3 was -12. So this formula shouldn't be scary. It's really doing something we've already done.